technology demonstration. So, because we have to set up everything, so the technology design, planning, that deep space mission, to even to have communication with it. To have deep space mission and things like that, and deep space mission is the communication from Earth to the aircraft or the spacecraft. Then we were also having various scientific objectives like to study the Martian surface features, morphology, mineralogy, morpho means shape, what is the surface of the the shape of the surface of the Mars, then mineralogy, and also to study the minerals, also the Martian atmosphere, its composition, and we were also very keen to know, we were keen to identify the presence of life in Mars, okay, the presence of life, and we were specifically looking at organic CH4 methane. We were very keen to identify the presence of methane, okay. So that if methane, organic methane is there, that is an indication of life, that is what we wanted. So, of course, whether it is organic or not, I mean scientists are able to. So, we wanted to keep track of it to ensure that we can identify. So, that is what we were trying, and so at least 5 payloads were there. At least 5 payloads were there. We need not worry much about that, but 5 different equipments. Five different equipments were there, right, and that is how it was then, and is still functional. Okay, please note, even though it was launched in 2014, Mangalyaan has not been, the mission is not yet over. Mission still functional. Okay. So, that is Mangalyaan, not Mangalyaan, Mangalyaan. Then we are also planning for a second mission, that is called Mangalyaan 2. So, we are planning to be there by 2022, we do not know right now, and maybe it may go up to 2025, it seems. Earlier it was planning for 22, but now it has been pushed back to 2025, and now again it will be an orbiter only. No lander, and no rover. As of now, we have not planned for a lander and a rover right now, but entering into another orbit. So, it is a critical test. So, that is what we are planning. Let us hope we will be able to do it. Now, let us move into another topic called International Space Station. Why the name Mangalyaan? Mangal means Mars, Yan means mission or rather journey. Okay. So, that is why Mangalyaan. Okay. Mangal is Mars, the Sanskrit word, Yan is the journey. Okay. That is why the name Mangalyaan. Now, coming to International Space Station. So, this is an experimental laboratory or a research laboratory which is revolving around the earth. It is a manned satellite. In the LEO, low Earth orbit. Okay, revolving around the earth in LEO, the low Earth orbit, and in fact, it is revolving at a slightly elliptical orbit of around 260 kilometers to 460 kilometers. Okay. And it is a joint, so it is elliptical orbit and it is just in the low Earth orbit, it is very close, it is not far away. Okay. And it completes one round in 93 minutes. And it completes 15.5 orbits per day. It completes one round in 93 minutes, so it completes 15.5 times. times in one day. And this is a joint venture between NASA, Russian Roscosmos, JAXA of Japan, European Space Agency and Canadian Space Agency. NASA, Russia's Roscosmos, JAXA by Japan, European Space Agency, so 5 space agencies are involved in the International Space Station. So, the main, since it is revolving around the earth, it is a massive one revolving around the earth. So, earth earth always attracts this to the center of the earth by the gravitational force. Okay, there is gravitational force, but the entire gravitational force is used as centripetal force to keep the object in orbit. Okay, the entire gravitational force is used as centripetal force. So, since that and it is used as centripetal force, we and the objects or other the astronauts who are traveling or who are inside the vehicle, they feel weightlessness. Or microgravity. They feel weightlessness or microgravity, because the entire the gravitational force, it is used as centripetal force to keep the object in orbit. So, the main thing is, in this laboratory, in this International Space Station, we conduct lot of tests and studies. So, this International Space Station acts as a microgravity and space environment research laboratory. Okay. Microgravity and space environment research lab, microgravity and space environment research lab. And the main, see, now we want to know in zero gravity how things function in astrobiology, astronomy. It conducts experiments in astrobiology, astronomy, meteorology, physics. So, microgravity and space environment research laboratory, it conducts tests in astrobiology, astronomy, meteorology and physics. Astrobiology, astronomy, meteorology, physics, etc. And it has evolved, this ISS was evolved from International Space Station, evolved from the American program called Freedom Space Station. American Space Station called Freedom. Okay, that is the original plan. Okay, that was in 1984. But the most successful plan or other space station was by Russia or Soviet Union in 1986. Mir station. Okay, and this International Space Station is there for the last 20 years, and it was launched in 1998 itself. Okay, I will come to that. Okay, the original plan, American Space Station Freedom, and also the Russian program Mir. Mir started they started early, but they launched in 1986, and it is the largest artificial object in space, and it has the size of a football field. Okay, it is the largest artificial object in space. Okay, largest, and it is it is observed, or we can observe it by using our naked eye. We can see this International Space Station traveling in the night sky. That is the beauty of it. And from Earth's surface we can see, and in fact the third brightest object in space, it seems, in the night sky, after Moon and after Venus, the third is International Space Station. In the night sky, the third brightest object is that we can easily view it. So, as I told you, around 260 to 460 kilometer orbit, and it completes in around 93 minutes, and it was launched in 1998. I already mentioned it is the first launch was in 1998, and the first long term resident, or the first astronaut in 2000, the year 2000, the first astronaut reached the International Space Station in the year 2000, and then it is continuously being upgraded. The latest module, the major, it has many pressurized modules. Many pressurized modules, and the latest one in 2021, a new module called Nauka. So, we are still in the process of developing and upgrading it. In 2021, a new module called Nauka was added, and earlier in 2011, a major addition was Leonardo. Another module, and an experimental inflatable space habitat was added in 2016. Okay, an experimental inflatable space habitat was added in 2016 earlier. So, on which line can be called as space? Okay, wo chodo. Anything beyond our Earth's atmosphere, we call it as space. Okay. So, since it is 250 to 460 kilometer radius, so it is generally called as space. Okay, that is what the concept is. So, now the main players have agreed that we will extend the life of ISS till 2030. That is decided in December 2018, that the life will be extended till 2030, and normally it has to constantly supply items and all, because the mission, the manned mission, they have to be brought back, they have to send up. So, normally there are the Russian launch vehicles called Soyuz, Progress, two launch vehicles by Russia called Soyuz and Progress. Then American program now, the SpaceX program called Dragon, Dragon 2, and also the European automated transfer vehicle ATV. Also Japanese one called H2 transfer vehicle. So H2 transfer vehicle. Okay. And till now in the last 20 years, 2000 onwards continuously, it is occupied 244 astronauts till August 2021, including some of the space tourists from 19 different nations visited. Okay, mostly Americans, more than 150 Americans out of 244. Okay. So, basically this will be acting as to conduct microgravity, especially our aim. What is the aim? The aim is to understand more before we conduct long term missions to Mars and beyond. If you have to send human beings to Mars and all, we would like to know more about the microgravity and related issues. So, that is why it is going to be a stepping stone. ISS, International Space Station, is a stepping stone for permanent occupation or of Mars. And according to estimate, the cost will be by 2030, the cost will be the 2000 to 2030, the cost will be approximately 100 billion euro. 100 billion euro is the cost, that is the costliest experiment which I have ever conducted. And as I told you, we need to know more about the microgravity in biology, in physics, because in future if we are planning for mission to Mars and all, manned mission, we need to be sure of what is going on, the scientific experiment and all we are conducting such a way that we have clarity regarding various scientific phenomena in microgravity conditions. Okay. So, it will also help to provide transportation, servicing and a staging base, okay, for providing as a stepping stone or a staging base for interplanetary missions, for diplomatic, educational, commercial, all these activities are there. So, it will also study the long term effects of space exposure on human body. Very important, when we microgravity, the effects of long term exposure of microgravity on human bodies. What will happen to muscles, bone loss, fluid shift, etc. Muscles, its effect on muscles, fluid shift. etc. Okay. So, these are some of the tests which were conducted. India is not part of it. It has been a very costly affair, right. So, right now Indian ISRO is not part of it. We are an observer in ISS, International Space Station, but not an active member, okay, not an active member of International Space Station. So, that is it. And these days we are also hearing a lot about space debris. Let me just talk about a few words about space debris. So, space debris is it is like an outer space pollution. The obsolete man-made space objects in beyond our atmosphere, the obsolete man-made objects in or beyond our atmosphere. This is what we are calling it as space debris. It may, in fact, eventually, so it is right now it is revolving around the earth, but slowly it will slow down and eventually it may fall back into the earth and it may enter the earth's atmosphere, it may burn up. Eventually will fall back, it will burn up in the earth's atmosphere. So, the biggest problem is these objects are traveling at very high speed. See, the orbital velocity, any object to be in orbit of the earth, it needs a minimum velocity. I said the orbital velocity near the earth's surface is 7.9 kilometers per second. The minimum velocity required for an object to be in orbit near the earth's surface, very close to earth's surface. But 7.9 kilometers per second, just imagine speed of sound 340 meters per second. Just imagine that. So, we are talking about many times the speed of sound. So, these objects have very high velocity. So, even if these are small objects, even if these are small, it has mass into velocity is equal to momentum. The momentum is very high. Okay. So, these objects have very high the space junks, and if you are looking at least 5,000 or 5 lakh, sorry, 500, 5,000, 50,000, 5 lakh objects or small pieces are revolving around the earth right now. 5 lakh pieces are revolving, and if you are talking about 7.9 kilometers per second, kilometer per hour, if it is there, how much is that? If you are talking about even 8 into 60 into 60 kilometers per hour per second into minute into hour. So, 3600 into 8. So, it is coming out to be around 28,800 kilometers per hour. 28,000 kilometers per hour, huge. So, the speed is very, very high. I just calculated from 8 into 8 kilometers per second. If you are multiplying, it is coming to 28,800 kilometers per hour speed. So, these are, it may be relatively small pieces, but the momentum will be very high. And then, second, so one is they have very high momentum. So, anybody, or even if it is a very minute piece, if it hits a satellite, or International Space Station, or even a an astronaut, it can be really dangerous. Okay. And also, so that is the first problem. If it hits, it can be really dangerous. Number 2 problem is, these space debris may disintegrate. It may collide with each other and it disintegrate further. They may collide with each other and disintegrate further. Okay. So, it may disintegrate further, and this phenomena of colliding and disintegrating further, it is known as Kessler syndrome. It is known as Kessler syndrome. Colliding with each other and disintegrating further, increasing the space debris. And the third problem could be, if large enough objects may come and reach the ground intact. Large enough objects okay. So, there can be problems. Now, we are also adding to this problem by conducting even anti-satellite tests. For example, China in 2007 conducted an ASAT, anti-satellite test, by destroying the satellite, and India also conducted. India destroyed our microsat. Hundreds of objects were thrown as debris. I already talked about that. India also conducted a test and destroyed the microsat. And hundreds of pieces were generated. Okay, hundreds of pieces were generated, and it's a mess, it's a problem, right. So, the military debris which is created, and unless we remove it, so it can be now another, the way in which, what is the way forward, we can destroy, we have to identify and we can destroy it by using laser. We can destroy it by using laser, but This can also be used to destroy a functional satellite also in orbit. It has a military connotation, can also be used. Can also be used to destroy a functional satellite in orbit also. So, anyway, but we can, but there are conscious effort going on these days to to clean up the space out of from the space debris, so that accidents can be avoided. So, that is the concept of space debris. So, this is in general about the space program, and I do not think when the rest of the things you might have whatever little is required, it is covered in the current affairs also, please utilize it. So, that is about the space program. So, now I will be moving into nuclear technology. So, let us see, and in the nuclear technology, India has good progress, because we have even conducted the nuclear test. We are one of the weapon states of the world. So, we have good technology, one of the best performing, like after space, or space and nuclear, both can be termed as one of the top scientific achievements of the country. Now, in the nuclear technology, first of all, I would like to talk about the Indian Atomic Energy Commission. Indian Atomic Energy Commission. So, in fact, the first setup, it was first set up in 1948. Okay. In 1948 itself. So, 1948 Indian Atomic Energy Commission was set up in the Department of Scientific Research. Now, only few classes are left. I mean, that is why only myself and Manish has to take. So, we are also busy in some other activities, like the interview training program is going on these days. So, that is why we are also slightly tightly placed. Okay. Anyway, so we please adjust a couple more classes only, and we are we do not want you to be suffering because of anything, lack of communication and all, but still if something is missing out, please forgive us. We are we don't want to inform, but we have information through WhatsApp also. I don't know how we are missing out. Let me see still. Anyway, tomorrow we have a class at 3. Please don't forget, I am starting at 3 again. Okay. So, please make sure that you are participating in it. Anyway, so in 1948, Indian Atomic Energy Commission in the Department of Scientific Research, then Department of Atomic Energy was created, DAE, created in August 1954, and then again in 1958 the Department of Atomic Energy Department of Atomic Energy Commission. So, earlier it was the Atomic Energy Commission was created in the Department of Scientific Research. Now, in 1958 once again changes were made. The Atomic Energy Commission was established in Department of Atomic Energy, Atomic Energy Commission in Department of Atomic Energy. Okay. So, Atomic Energy Commission in 1958 was when in fact, Department of Atomic Energy directly under Prime Minister Nehru, that was in 1954. Then Atomic Energy Commission in the Department of Atomic Energy in 1958. So, again this was under, so Atomic Energy Commission came under Department of Atomic Energy only in 1958. So, according to the and a resolution, in fact, in a government resolution of 1958, this is through a government resolution of 1958, right. And the Secretary to Government of India in the Department of is ex officio chairman. The Secretary to Government of India, Department of Atomic Energy, is the chairman of the Atomic Energy Commission. Okay. Secretary to Government of India, Department of Atomic Energy, is the chairman of the Atomic Energy Commission. So, that is how the Department of Atomic Energy Commission is there, and it is department under the Department of Atomic Energy, which was started in 1954. So, that is the nodal agency in for energy production as well as for research in atomic energy, both are done under department. So, and department. So, finally, the bottom line for you is Department of Atomic Energy directly under Prime Minister. Even today, Department of Atomic Energy is directly under Prime Minister of India. Okay. And since 1954, Prime Minister Nehru at that time, he created it. Subsequently, all Prime Ministers kept Department of Atomic Energy directly under the Prime Minister only. Now, coming to nuclear research in India. Before that, when we talk about the nuclear technology, a couple of points I would like to add. Nuclear energy and nuclear technology, we are talking about two different aspects. One is the nuclear fission and the nuclear fusion. Okay, there are two aspects, nuclear fission and nuclear fusion. See, fission is the heavier nuclei. If they break down, then it is nuclear fission. Similarly, if a lighter nuclei if they merge or if they fuse together, in both the cases energy is released. Okay. Why? Because according to Einstein, Albert Einstein, E is equal to mc square. Energy is equal to mass into velocity of light square. So, during fission, some mass is converted into energy. Similarly, in fusion also some mass is converted into energy. So, when an object breaks or if two nuclei merge together, there is some energy, some mass is converted into energy, and this missing mass is called mass defect. Okay. See, for example, say you take a helium nucleus, please remember, in hydrogen, in the nucleus it has one proton and no neutron. Please remember, 0 neutron and 1 electron which revolves around, the hydrogen nucleus. 1 proton, 0 neutron. The only element in the world where there is no neutron is hydrogen. 1 proton, 1 electron. Then comes helium. Within the nucleus, there is 2 protons and 2 neutrons, and surrounding it 2 electrons are revolving. Two electrons revolve around the helium nucleus. Now, the atomic weight of helium or the helium nucleus, or the weight of helium nucleus, observed that if you weigh helium nucleus and also if you weigh 2 protons and 2 neutrons separately, suppose you take 1 proton, you take another proton, plus you take 1 neutron, another neutron, add its weight. Individual weight, and look at the weight of helium nucleus. Ideally, what do you expect? This helium should at least weight equal to 2 protons plus neutrons, or even more than that. It may be, it's a nucleus, so it's together, so it may be some other particles also. But what is found is the weight of the helium nucleus is less than the weight of individual 2 protons plus 2 neutrons. Okay, you add up proton plus neutron weight, and you look at the weight of 2 proton plus 2 neutron in a, you take a helium nucleus, you will find that the weight of the helium nucleus is less than the weight of the individual 2 proton plus neutron. That means there is a defect in the mass defect, and this missing mass is the binding energy. That is what we say, the missing mass is the binding energy. So, there is a mass defect when you fuse together protons and neutrons into a helium nucleus. Similarly, during fission, heavier nuclei, see like uranium, protons at 92, whereas neutrons are say 146. Okay. Now, in a uranium heavier nucleus like or nuclei like uranium are unstable, and they tend to break down. They tend to break down into smaller nuclei free neutrons is some energy. And why these heavier nuclei like they are unstable? Because of the asymmetry in the proton and neutron number. All elements above lead are unstable. They break down by themselves. Their nucleus, it break down by themselves. Why? Because of instability. They are unstable. Instability is in the proton is to neutron ratio. In smaller elements, proton neutron ratio is same, 1:1. Say you take helium, 2 proton is to 2 neutron. Carbon, 6 proton is to 6 neutron. Oxygen, 8 proton, 8 neutron. All elements, say lithium, 3 proton, 3 neutron. Name any smaller element, proton and neutrons are same, 6 proton, 6 neutron in carbon. But you see uranium, 92 protons, 146 neutrons. So, there is a huge difference in the number of neutrons, and this asymmetry is the problem, and that is what is creating instability. So, those elements which can break down by itself and release energy, those elements are known as radioactive elements. So, Namrata is asking, sir, please show the slide above. अरे यार 1 minute, तुमको slide दिखा के जाऊँगा. So, I was just talking about the Indian Atomic Energy Commission in the beginning. 1948 it was created under Department of Scientific Research. Then Department of Atomic Energy was created in 1954 under Prime Minister Nehru. 58 Atomic Energy Commission was kept under Department of Atomic Energy, and the secretary in the Department of Atomic Energy, Government of India, Department of Atomic Energy is the chairman of the Atomic Energy Commission. That is the only thing I said in the beginning. So, Department of Atomic Energy is directly under the Prime Minister. Then I was talking about fission and fusion. Fission is the breaking down. The heavier nuclei will break down, lighter nuclei can fuse together, and in both the cases Einstein's formula E is equal to mc square. Mass is converted into energy, the missing mass is called mass defect. So, I said in the helium, we are talking about that. So, now in fission, say in uranium, so these unstable elements will break down. So, what radioactive elements? So, what are radioactivity? What is radioactivity? The spontaneous emission of radiation. Radioactivity. Okay. So, radioactive elements are those elements which can break down by itself, the spontaneous emission of radiation by way of alpha, beta and gamma rays. Okay. The entire radioactive, the electromagnetic spectrum, energy, even gamma rays, even some light, heat energy, everything is produced. The radioactivity, spontaneous emission. What is alpha? Alpha rays is nothing but a helium nucleus, 2 proton and 2 neutron. Beta is nothing but 1 electron. Okay. okay, spontaneous emission. Then gamma, gamma is nothing but electromagnetic radiation, gamma is nothing but electromagnetic radiation. We have seen X-ray, gamma ray, ultraviolet, visible, infrared, microwave. So, it can be infrared, heat energy can be produced, gamma rays can be produced, gamma rays, okay, even visible light can be produced in the electromagnetic. So, depending upon the different molecules or different nuclei, it may produce different electromagnetic radiation, but gamma rays are very commonly produced. Ultraviolet can be produced, infrared is produced, visible light is produced, infrared is nothing but heat energy is produced. When a nucleus breaks down, it can. So, the spontaneous emission of radiation is radioactivity by way of alpha, beta, gamma rays, and any element which can break down by itself is a radioactive element. Any element which can break down by itself is a radioactive element. Any element which can break down by itself is a radioactive element. So, all elements above lead, Pb, lead, atomic number 82, all elements above lead in the periodic table are radioactive elements. Uranium 92 is the heaviest naturally occurring element in the world. Uranium 92 is the heaviest naturally occurring element in the world. Plutonium 93, it is not found in nature, naturally it is not found. Plutonium can be produced only in a reactor. Plutonium is an artificial element, not found in nature. So, all elements above uranium can be artificially created in a laboratory or in a reactor, but not found in nature. So, anyway, uranium is the heaviest naturally occurring element in the world, I already told, 92, and these uranium has many isotopes. What are isotopes? Isotopes are different mass number, but same atomic number. Please remember, proton number is equal to electron is equal to atomic number. Hydrogen, 1 proton, 1 electron, so atomic number of hydrogen is 1. Helium, 2 proton is equal to 2 electron is equal to atomic number. Helium's atomic number is 2. Lithium 3, oxygen 8, carbon 6, uranium 92, proton number and electron number is same. But when we say mass number, mass number is the weight of proton plus neutron. Neutrons have no property in terms of chemical. In the chemical property, proton number matters, that is all. So, for the same element there can be different neutron numbers. Same element, I am just telling you something very elementary which you know, but I am just repeating. Same element, but